says anything raised to the 0 power is equal to 1. So for example, if I have 3x in parentheses, the key is that it is in parentheses, and that's raised to the 0 power, it just equals 1. If I have 5 raised to the 0 power, you guessed it, that's just 1. And if I have a fraction, such as 1/2, raised to the 0 power, because it's in parentheses like that, the entire thing just equals 1. The second rule says when you have a negative exponent, and here's where it comes a little tricky, if it's in the numerator, you move it to the denominator, and if it's in the denominator, you need to move it up to the numerator, and then the power magically becomes positive. So for example, if I have 7 raised to the negative 3 power, I need to take my 7 and move it from the numerator down to the denominator. So it's going to now become over 7 raised to the positive 3. So what do I have that I left up on top in the numerator? There's nothing there, but I don't want to put a 0. That's the implied 1. So I end up with 1 over 7 to the 3rd power. If I have x to the negative 4, it works the same way. Instead of the x being in the numerator, it's going to move down to the denominator, and that 4 is going to now be a positive 4. But remember, I can't just leave it blank up top in the numerator. I put a 1. Now I have 3x, and that quantity is raised to the negative 2, and that's all over y. So what's the exponent on my y? It's 1, it's positive, so the y can stay right where he is. It's just this 3x up on the top that has a negative exponent, so it's what needs to move. So I'm going to draw my line, and instead of having 3x up on the top, it's going to come down to the bottom. That 2 becomes positive, and remember, my y was okay hanging out down there, and I've got a 1 up top. Lastly, I have 4y over the quantity 7x raised to the 6th power. Is my 4y doing okay up there, or do I need to move it? Well, the exponent on my y is what? It's 1, which is positive, so he can hang out up there, that's fine. But this down here, I have this negative 6, which means I need to take my 7x, and he's no longer going to be on the bottom. He's going to move up to the top, right? But don't forget, he's in parentheses. Well, what did I leave down on the bottom? Well, I moved the entire thing. It's just 1. So I can just simply write 4y times 7x, and that's raised to the 6th power. Well, let's say this time I have an entire fraction that's raised to a negative power. So really that's saying that 2x needs to move down and that 3y needs to come up. So I'm just going to flip it the whole thing. So my 2x will move down, my 3y will move up, it stays in parentheses, but my 3 is now a positive 3. Works if we have a 0 power or if we have a negative power. Let's actually apply that. So if I want to evaluate an exponential expression, I just plug in the values for the variables and follow my exponent rules. So number 1 says evaluate 3s cubed t to the negative 2 if s equals 2 and t equals negative 3. Well, I'm just going to substitute in a 2 where my s is located and a negative 3 where my t is located. So I have 3 times, again, my s is 2, and that's raised to the 3rd power, and then t, which is a negative 3, raised to the negative 2 power. PEMDAS tells me that I have to do my parentheses first. Well, I don't really have parentheses here. Those parentheses are there just to show me where my exponents go. So next I have to do my exponents. So I'm going to look. This first one here is 2 cubed. What is 2 cubed? It's 8. So I end up with 3 times 8, And then I have this negative 3 raised to the negative 2. But it's a negative exponent, so what do I need to do to it? I don't like negative exponents. I don't understand those. I'm going to move it. So it's in the numerator right now, so I'm going to move it down to the denominator. So I end up with a negative 3 squared. Notice that only the exponent changed sign. What was inside parentheses stays negative. Just because it moved, it doesn't change. Okay? So what is a negative 3 squared? It's positive 9. So I really have 3 times 8 all over 9. But what's 3 times 8? Okay, it's 24 over 9. Can I simplify that? Well, I actually can. What are they both divisible by? I can divide them both by 3, right? So 24 divided by 3, well, I actually did that right there. It's 8. And 9 divided by 3 takes me back to 3. Number 2 says to evaluate the following if n is negative 2 and w is 5. Well, before I even substitute n, I'm going to actually rearrange a few things. I see this w to the 0 power, and I immediately know what does that equal. Anything raised to the 0 power is 1. That's just going to go away to a 1. So then I really just have n raised to the negative 4. Well, it's a negative exponent. I don't like negative exponents, so I need to move it. So it really becomes 1 over n to the 4th power. Now that I've simplified it, I can actually now substitute in my n value, which is a negative 2. So I have 1 over a negative 2 raised to the 4th power. So what does that actually mean? Something raised to the 4th power. What am I doing? I'm multiplying it that many times. So I can really just rewrite this as a negative 2 times a negative 2 times another negative 2 and yet one more negative 2. Well, negative 2 times negative 2, that's going to equal a positive 4. A negative 2 times a negative 2 is a positive 4. 4 times 4 is 16. So my answer here is 1 over 16. Letter B says n to the negative 1 over w squared. Again, I have a negative exponent. I don't like that. Let's move it. So my n moves downstairs, and it becomes a positive 1. And my w squared, that squared is positive, so I don't need to move it. It stays where it is. I got that scenario again where I don't have anything up top, so what do I put? That's right, I can put the 1 hanging out up there. All right, so let's plug in my negative 2 for n and my 5 for w. So I have a negative 2 to the 1st power. Well, that's just a negative 2. And I have 5 squared. What's 5 squared? 25. And I multiply the 2 together, and I get negative 50. So my solution is a 1 over a negative 50. If you want to rewrite that and have that negative float up so that it's a negative 1 over 50, that's acceptable as well. Moving on. C. I have n to the 0 power. Oh, wait, I see a 0. What can I do? That's right, I don't need that whole thing. It just goes away to 1. And then I've got w to the 6th power. So I have 1 over w to the 6th. Are you guys having fun yet? This is so much fun. All right, my w is equal to 5. So I'm going to plug 5 in back down here for my w. So I have 1 over 5 to the 6th power. That's a lot of 5s, but we got this. All right, here we go. 1, 2, 3, 4, 5, 6. All right. 5 times 5, 25. 5 times 5, 25. 5 times 5, 25. Whew, a lot of 5s. Here we go. You guys know what 25 times 25 is? Well, let's see. I trust that you can figure this out, and if not, pause real quick, grab a calculator. Or pause and write it off on the side. Okay, somebody get it? All right, 625. And I need to multiply that by 25, and I get, ooh, this one's a big one. You ready? 1, 5, 6, 2, 5. Woo, put in my comma, box it in, and I'm done. Oh, wait, am I? What did I just do? Did you guys make the same mistake I just almost made? Don't forget that this is actually downstairs in the denominator. So this isn't even my answer. This is really supposed to be 1 over 15,625. That's actually a really tiny number. Woo! That was a lot of arithmetic. Last problem. We got this. Let's move the page down a little bit so it's easier to see. I got some more working room here. And just to make sure, I'm going to change colors as well. All right. So I have 1 over nw to the negative 1. Well, that negative 1, what is it attached to? Is it attached to the w or is it attached to nw? Well, I don't see any parentheses combining the n and the w, so that negative 1 is just attached to the w. So really, this is like saying 1 over n times w to the negative 1. So my n exponent is a 1, which means it's happy down there. It doesn't need to move. It's just the w that has a negative exponent, so only the w needs to move up. And they're both 1 exponents, so I just need to plug in. What was my w value again? It was a 5, and my n value was a negative 2, so my answer is 5 over negative 2. But again, you could also have that negative float up so that you get a negative 2 over 5. Pretty awesome, right? Okay. You'll notice that your homework is going to be on page 417, and you're going to be doing numbers 9 through 43, but you only need to do the odd ones, okay? So good luck. Have fun.
Take a look at number 10. We like number 10. I don't really care what's in here because anything raised to the 0 power is 1. So the answer number 10 is 1. Number 12, it's just a little bit tricky. Notice there are no parentheses. So according to order of operations, please excuse my dear Aunt Sally, you have to make sure that you deal with the exponent first. So the negative is going to wait. This is 5 with a negative 2 exponent, so it's going to be 1 over 5 with its second. The negative stays out front, 1 over 25. Negative 1 over 25. 14, we have 2 raised to the negative 6. Negative exponent will be 1 over 2 to the 6. All right, this is 2 times 2 times 2 times 2 times 2 times 2. 6 of them. That's 4, 4, 4. So that gives us 1 over 4 times 4 is 16. 16 times 4 is 64. So 1 over 64. All right, let's take a look at number 16. Number 16 is negative 12 raised to the negative 1. No parentheses, so negative 12 over 1 if you want to get technical, which just gives us negative 1 over 12. And 18, 58 raised to the negative 1. Tells it to go to the bottom, 58 to the 1. We know anything to the 1 power is itself, so 1 over 58. Okay? Last but not least, let's take a look at 20. This is in parentheses. So it would be 1 over, and the negative 5, the whole thing goes down, raised to the third power. So this is 1 over negative 5 times negative 5 times negative 5, which gives me 1 over negative 125. Okay, moving on. Simplifying each expression, let's take a look at some of these. 22 is 1 over x to the negative 7. Because that's a negative exponent, it wants to move up top. So it becomes x over 7, and then there's a 1 there. So we can just write it like that. 1 over c to the negative 1. Again, that's negative. We'll move it up top. So it's just c over 1, or c. 26, k to the negative 4, and j to the 0. Anything to the 0 power gets replaced with 1. So this right here turns to 1. Over here it's k to the negative 4, so that's 1 over k to the 4. Anything times 1 is itself, so it's just 1 over k to the 4th. 28, it's going to start getting a little more complicated. Just take things one at a time. All right, so this 7 is fine where it is, no exponent. A, it's fine, no exponent. B is negative, so it wants to go down here. 3, no exponent. W, no exponent. So the only thing that happens, everyone stays in its place, the 7, the A. This is going to move down here and join these guys, and we're done. Okay, moving on. I'm just going to change screens, give us a little more room. Number 30. C to the negative 5, D to the 7. This is negative, so I'll create a fraction. It wants to go down below. So C to the 5. This was positive, so it'll stay up top. C and D have different bases, so we're done. 32. 7s over 5 t to the negative 3. This is the only one with a negative exponent. It's going to want to travel up here. So we have 7. We have s. T is to the third power up top. This 5 did not have an exponent other than 1, so it stays on the bottom. 34. Okay, so this has a negative exponent. This has a negative exponent. This one's going to stay up top. So this 2 to the negative 3 goes down here. X squared stays up top. This guy, negative exponent, is going to come down below. Now, let's clean this up. X squared, we have 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8, so that turns into 8. Z to the 7. All right, let's take a look at 36. 7, s to the 0, t to the negative 5, 2 to the negative 1, m squared. All right, so let's talk about what happens. 7 stays up top, it's fine. This turns to 1. Well, what's 7 times 1? That's 7. This has a negative exponent. It's going to want to go down below. This exponent is negative, so this 2 with the negative 1 will want to travel up top. And this m squared, it's fine. It stays where it is. Now our final step, 7 times 2, that's 14. M squared t to the 5th. Moving to the last little section, we want to evaluate, place r, replace it with negative 3, s with 5. So on 38, you have s to the -3. So instead of s, we're going to replace it with 5. 5 to the -3 means 1 over 5 to the 3rd. So that's 1 over 125. 40, s to the 0 over r to the -2. Well, s to the 0 is 1. This r to the -2 will travel up top. Nothing's left on the bottom. We're going to replace r with -3. So we have 1 times -3 squared. 1 times 9 is 9. Remember, a negative times a negative, because that's inside parentheses, will be a positive. Let's take a look at 42. R to the 0, we know is 1. S to the -2. So this is 1 times 1 over s squared. We're going to replace s with 5. So this is 1 times 1 over 5 squared. 5 squared is 25. So 1 over, we get 1/25. 44. 2 to the -4, r cubed, s to the -2. Well, let's clean this up. Negative exponent goes on the bottom. Positive exponent goes on top. Negative exponent goes on the bottom. Now, we replace this r with -3. We're going to cube that. 2 to the 4th, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then we're going to multiply that by s squared. Well, s is 5, and 5 squared is 25. So on the bottom, we have 16 times 25. Okay, take a moment, figure out what 16 times 25 is. That's 400. So on the bottom, we get 400. On the top, we've got -3 times itself 3 times. -3 times -3 is 9. 9 times -3 is -27. So we get -27 divided by 400. -27 divided by 400 is our final answer.